ขอเรียนเชิญอาจารย์แอนโทนีนะครับขึ้นมาบนสเตจ
Okay, so I'm really excited to come and talk to all you Android and web developers about iOS and Firebase today. So, do we have any iOS developers in the house today? Ah, a few. Good, good. Okay, so I feel a little bit safer now. So, I teach at Naresuan University, and we also have an app development company called Apptitude. And we've been using some Firebase technologies for about a year now. We've started to use them more and more in production applications. And so today I wanted to not give you just a hello world about Firebase. I actually want to show you how we're using it in real applications. So the first thing I'm going to say is similar to this morning's presentation, as an iOS developer, if I go back a few years and I needed to develop a iOS application that connected to a server to download or send data, then I had to go through quite a few steps. So first of all, before I can write any code on iOS, I need some back-end database and web services. And then if I come back to iOS, I would have to write some code to call the web services. And then I would have to write some more code to deserialize my JSON into objects, and then finally I would bind my data to the UI. So it's quite a long process. So as you saw this morning, our life is getting much easier now with Firebase. Instead of calling all those parts, now we can call Firebase and bind our Firebase objects directly to our UI. So the technology I'm mainly going to be talking about in this talk is Firebase Storage. In a few more talks, you're going to find out more about authentication on iOS and later about database. So very, very quick introduction, because really, if you want a quick introduction, you can go read the tutorial on the Firebase docs. This will just give you a quick introduction. So basically, Firebase Storage is a way for you to store large objects, files, up to 5 terabytes. And this might include things like user content. So if you have a chat application and you're uploading images, or maybe you have some other type of application where the user can upload content. And also, a way that I use Firebase Storage quite a lot is for static content. So often our clients want projects where they can change the pages dynamically. So maybe I'm using a combination of Firebase database and also HTML content that I'm storing in files on the server. Traditionally, I would have used AWS S3 for this, but now I'm finding I can use Firebase Storage. So why Firebase Storage? The first reason, if you go look at the Firebase website, is that Google says that it's very robust. So if you try to upload an image and it fails, there is a lot of hooks in to resume, pause your uploads. So it's a lot safer than writing your own code. The second is it's secure. So you can write security rules based on the Firebase authentication to set permissions on your files in Firebase Storage. And thirdly, it's very scalable. So you have almost unlimited storage at your disposal. On iOS, and this is similar to Android as well, if you want to upload a file, it's a 3-step process. First of all, you create a storage reference. Then you create an upload task. And finally, you can observe the progress and the completion of that task. So now for a little bit of code for you. So how that would look like in Swift, you would create this reference to an object that you haven't yet created. And then you would create the upload task, which would take some data. So if you were using a UI image, you would first turn that UI image into a data object and then upload that to the server. And finally, you would observe the progress and completion of that task. So what you would get in Firebase Storage Console is you would see like a directory of files. So Firebase Storage is nothing really very special. It's just like directories of files. Quite often, we will use this with the real-time database as well. So the real-time database, I would have file names that I'm going to reference in Firebase Storage. I'm going to show that to you in the demo in just a moment. And then so there's only two types of operations. There's downloading files and uploading files. Downloading files is very similar. You create a storage reference. First of all, you get a URL to the file, and then finally you download the file. Downloading the file, you can actually use any library or technique that you want to download the file. So create a storage reference, the same as before. Get a download URL. So notice that this is a closure in Swift. So getting the download URL is not a synchronous action. It's something that may require a call to the server to check that that file exists and that you have permission to access the file. So once you get returned back from that closure, you'll have a URL, and finally you can use whatever library you want. Here I'm using AlamoFire to download the data. Okay, let me give you a bit of a demo of how this works in practice. Okay. So today, for my demo today, I'm going to use a events app. So this is something typically that I would do when I'm creating an application using Firebase. I've got a table view of content that I'm loading from Firebase database. Okay, I'm not going to talk much about Firebase database, but I hope you can understand that I'm getting a list of events from Firebase database, and I'm deserializing them and calling reload data on my table view. So at the moment, my table view is quite simple. It has this is going to be an image view, and this is the title of the event. If I scroll down to take a look at my cell for row at, so I'm using this event table view cell, and I'm setting the event that I've got from the database. Okay, so I haven't started any storage yet. So my next task is going to be to load an image from Firebase Storage into a UI image view in the table view cell. So let's move across to the table view cell and see how I would do this. So at the moment, the only thing I'm doing is loading the title of the cell. So now I want to load my image. So the first thing I'm going to do is create a storage reference. So as you can see, this is very similar to the JavaScript you saw this morning. In fact, if you've used the JavaScript and you transfer to either Android or iOS, you'll find it very easy because it's almost the same, just different syntax. So this corresponds to the image. I'll just quickly show you on my console. So if you look in the storage, I have some images. And if I click in here, you can see the images that I have in the directory. And so here I'm loading from the root of Firebase Storage into the images directory, and then some image name which is stored in Firebase database. Okay? So then this is to create the storage reference. The second part is to get the download URL. So this doesn't download the file, this purely gets the URL for the file. Okay? And then finally, the final thing to do would be to download the file. So I've created a category on UI image view to help me do the download called setImageURL. And here I will just pass the URL into that category. If you want to have a look at the implementation of this, so you could actually use any library to download your image. Here I've written my own URL session data task just to keep it simple. Okay, so that's these three steps are all I need to do to start downloading images. So let's try and run this program again. Okay, so now all these images are being loaded from Firebase Storage. As I scroll down, you can see it's loading more images. This is great. Very easy to do this basic step. And this is what the tutorial on Firebase shows you how to do. The problem with this is when I start scrolling down and scrolling up again, it's a bit slow to reload my images. Okay? So there's no caching going on at the moment. Each time I scroll up and down, it's reloading the images from the server. So I'm using up all my Firebase credits for downloading all these images. And I'm also making my app a bit slow in the process. It's even worse when we look at the network. This is a tip for you when you're developing apps, to take a look at the network and try scrolling down and notice as I scroll down, it's hitting the network, and as I scroll back up, it's hitting the network. Okay, that's the slowness in this project. So let me go back to the slides and talk a bit more about this. Okay, so the next requirement that I often find with applications is that I want it to be able to work offline, or I want the application to be able to cache the information. And if you think about traditionally how I would develop this as an iOS developer, when I'm deserializing my objects, I would need to cache the results, and maybe some of you iOS developers have tried this. Maybe you've cached your JSON files or cached your image files, or maybe you have used SQLite to cache the data, or maybe you've used Realm as a way to deserialize your objects and then keep them in Realm so that they can be used offline. These are all good methods, okay? But it's a lot of extra code that we have to write for caching. So with Firebase database is really, really cool, and I hope some of our other speakers are going to talk about this later. So on Firebase database, if you want to persist your database on the device, you can write one line of code to say database persistence enabled, and you can make calls to the database, and as long as the data is already cached, the application will continue working. So that's great for Firebase database. However, what about our user content? What about the images that our user has uploaded? What about our static app resources? Well, there is no persistence enabled for Firebase Storage. And this creates a bit of a problem if you want to build offline applications. So the main part of my talk today is going to talk about how we can use Firebase Storage and do some caching to really build a truly offline iOS app. So I'm going to switch back to my my cell, and just remember that previously, when I was loading some data from Firebase Storage, I had these 3 steps to create the reference, get the URL, and download the file. So now what I want to do is I want to do some caching in between these different steps. So let's take a look at a very basic approach to caching on iOS. And this is not perfect. This is just to give you an example of where you might start if you were doing some caching. So here I've started by creating NSCache, because this is the default way to do an in-memory cache on iOS that maps a string, which is going to be my key, to a Firebase storage file, to a UI image. And you'll see now that I have the same
basic structure that I'm going to get a storage reference and download the URL and then get the file. However, I'm going to check whether the file is in the cache before I try to download the URL and download the file. So I use the image reference as my cache key, and then if this image is in the cache, then I can load this image directly onto the image view. Otherwise, I can get the URL, download the file, load the image onto the image view on the foreground thread, so not on the background thread, because the download image occurs on the background thread. And then finally, I can save my image in the cache for later. Okay, so this code is something that I've prepared earlier and is ready to run. So let's give this a go. So I'm going to choose my second link now, which is using NSCache. Okay, so the same as before. It looks exactly the same. And as I scroll down the first time, it is exactly the same. It's downloading the images from Firebase Storage. But now, look what happens when I scroll back up. So there is no delay now. All those images are in memory, and so my table view scrolling up and down is much smoother. And I can prove that to you, because now I can look at the network, and if I scroll down and I scroll back up, there is nothing happening on the network. It's making no calls to Firebase because it's using all the images from memory. Okay, that's great, but what happens when I stop the application, the memory is cleared, and then I open the application again? Well, the memory has now been cleared. All the images need to be re-downloaded from Firebase Storage again. So now when I'm loading the data again, I have to wait for the images. So it's not an offline app yet. It's just made the UI a bit smoother. So the next phase is I'm going to introduce a disk cache. Okay. I don't think there is any disk cache out of the box on iOS. You have to go and find a library for doing disk caching, or you have to write your own. So ideally, what I'd like to be able to do is simplify everything in my design. So if you look at my basic cache table view cell, there's getting a lot of code in there for doing the caching. So I want to simplify this. So what I'd like to be able to do is start with an image reference and then just call on the image view, set image, and give it a Firebase storage reference. And then I would like two things to happen. If that file is in the cache, then just load it directly on the image view. Else, download the URL, download the file, store it in the cache, and set it on the image view. So I've created several classes to help me do the caching here. I'm going to show you a couple of those. So my set image is an extension on UI image view, and this is going to call this class called a Firebase Storage Cache. Okay, this is not from Google. This is part of my project. Okay, and once it gets this file downloaded, it will set it on the image of the UI image view. And a quick look at Firebase Storage Cache. So in the Firebase Storage Cache, I'm doing very similar to what I showed you with NSCache. I'm checking if it's in the cache or not, loading it on, returning the file, or I'm going off to download the file. Okay, what else is there to explain? So finally, on my table view cell, the code is now quite simple because I'm just calling these other cache classes that I've created. Let's show you what happens now if I run this. So I'm now not using NS Cache. I'm now using Firebase Storage Cache. Okay, I'm first of all going to, the first time I'm downloading the files and storing them in the disk cache, and as I scroll down, I'm loading. Actually, I should switch back to look at the network. So as I scroll down, I'm still loading these files. But now as I scroll back up, it's smooth, the same as the in-memory cache, because there's very little difference on iOS between loading from memory and loading from disk. Loading from disk is pretty quick. And the great thing about this now is that I could stop the application. I could switch off the internet. That's not going to work, is it? Because I'm going to lose. If I switch off the internet, I'm going to lose the Wi-Fi. There's a bug in my presentation. Any ideas? Is there anything else I can do here? Unfortunately, the iOS simulator doesn't give me any options to switch off the... You're going to have to trust me then. You're going to have to trust me that I cannot switch off the internet. I could do it if I was on my phone, actually. So you have to trust me now that if the internet was off, this would still work. You can actually go try it for yourself afterwards. What I can show you is that watch this. When I click Firebase Storage Cache, there's going to be very little network. Okay, there's going to be a tiny amount of network. Okay, this tiny amount of network is because Firebase Database is not using the cache yet. Okay, so let me just show you how. So talking about Firebase Database now, if you want to enable, you know that slide when I said the developer can go for a vacation because there is not much work to do for persistence on Firebase Database. If we write this one line for Firebase Database, now the data can be cached. I think I have to run this one time first for it to be persisted. Okay, so my database and my storage files are now persisted. Just check these are all loaded. Okay, and let's stop this, and let's run it again. Let's get the network up. So now I'm expecting 0 access on using Firebase Storage. Well, there was a little bit. Maybe Firebase is doing some checks in the background, I'm not sure. But if there was no internet, you could still run this example. I did test it before the demo. You can go try it at home. Okay? So this is really good for loading images, okay? And what I found was after I had done this for loading images, I wanted to do it for other types of file as well. So a common requirement in some of our applications was to load HTML content into a UI web view or a WK view. And so I've done something similar for HTML files. So this is actually an HTML file that is being cached using Firebase Storage. Here's another one. These are both HTML files. So how does this one work? So if I go back to the library, so I had an extension on UI image view. I've also got an extension for UI web view. If you want to load some HTML content, then you can do that using the Firebase Storage cache. How does this work on the view controller? So well, there's a few ways it can work. You can, if you just want to download an HTML file and stick it in a UI web view, you can call it in one line, web view load HTML with a storage reference. If you want to do some processing on your HTML, so quite often I want to download some HTML from Firebase Storage, and I want to change the margins because the margin on iOS and Android is different. Maybe I want to apply some color scheme on my HTML. So I've got some post-processing closure that adds some extra CSS style into my HTML before it loads onto the web view. So this is all handled in the extension. Okay, that's most of the demo that I wanted to show you. So let me quickly go back and finish my slides. Okay, so a little about Firebase Storage Cache. So this is a summary of some of the things that we did just now, very, very quickly. So with Firebase Storage Cache, I can create a cache for Firebase Storage. I can set a duration for how long the files can be stored. And then I can use the cache directly to get a file from a storage reference. And I've also created some extensions for UI Image View and WK Web View. I think it's quite fun to play with caching on iOS and also on Android. So I encourage you to go and try this for yourself, to build your own caching mechanisms, because you will learn a lot more how to build a performant iOS or Android application. So some things to remember: memory cache is really good if you want to reload lots of images within the same view, but it's not very good if you want to build an offline app. If you want to build an offline app, you're going to need a disk cache. An important thing to remember with Firebase Storage is that the key for the cache should not be the download URL. The download URL may change, okay? So that's why you have to, each time you want to download a file in Firebase Storage, you must first get the URL before you can download the image. So make sure you use the reference as a cache key, not the URL. And also don't forget to put some time or some size limits on your cache. Otherwise, your cache will keep growing and growing in size, and you won't delete the old images. So I've been using this maybe for about a month in a production app, and it seems to be working okay. There's still a few bugs and still some improvements that I would like to make to this. But just last week I've added it to CocoaPods, so you can go and grab it and try it out for yourself and use it in your own projects. There is a separate project called Firebase Offline App Demo, which is the demo that I showed you today. So you can go and try this out. If you find some problems, feel free to let me know. Or if you want to continue developing it yourself and send me pull requests, then that's cool as well. So that's the main part of my presentation. Thank you all for listening, and I hope you were able to understand my English. Some people were requesting that I speak Thai. If you have any questions, I think we have time for questions, right?
Yes.
Okay, cool.
Okay. Anyone have question? มีไหมครับ เดี๋ยวผมเดินไมค์ไปให้ เดี๋ยวแปลให้ด้วย มีไหมใครเขียน iOS ขอคำถามหน่อยฮะ
มีคนเขียน iOS เห็นมาหลายคนแล้ว
อาจารย์พูดภาษาไทยได้ครับทุกคน
เขาน่าจะอายนิดหน่อยเพราะว่ามี Android Dev เยอะ
อ๋อถามได้เลยนะฮะ มีไหมเอ่ยทุกคนแบบนั่งฟังมาตั้งนาน
ไม่มีใครกล้าถามแล้วใช่ไหมครับ
Okay.
No questions. Well, then we can move on to another Thai presentation.
ขอบคุณอาจารย์แอนโทนีมากเลย
Okay, thank you. Thanks very much.
ขอบคุณครับ